Well, hopefully this is the last video on this Yaesu FT-901DM. And this video, if I am able to fix it, is going to be on the counter unit here, which doesn't work. As you can see, as I change the band here, none of the digits make sense. Here's 10 meters, it says 15. 15 it says 8, 20 it says 1. So we've definitely got a problem here. Here's a schematic of the counter unit here, and I think the first thing I'm going to do is I'm going to verify I have the proper voltages. 13 volts comes in here on pin 2 of this connector here, so we need to make sure we're getting the proper voltage there. And then also there's two regulators. There's a 5-volt regulator here that feeds the logic here. But then this chip here, Q03, it's a SN76514. This needs 8 volts, so there's a 8-volt regulator here. So I need to make sure I get 8 volts on pin 2, and apparently that's the only load that 8 volts is on, and it's a small 78L08. It's a small regulator to provide the voltage for this chip. So the first thing I want to do is make sure I'm getting the proper voltage here. Which I am, 13.59. And then to pick up and measure the output of these regulators, I'm going to go, they're kind of buried in here, so I'm going to go to pin 2 of Q3 and measure pin 2, which is here. And hopefully I don't short the pins together, which has been done. And I have 8 volts. And then to measure the 5-volt output, all I have to do is go on any of the supply pins of the IC chips here. For instance, I can go to pin Q12, pin 7 or 8, and Q12 is right there. So here's pin 7. Need 3 hands to do this without shorting something out, hopefully. And we got 5 volts, 5.02 volts. So we're getting the voltage there. So we need to look a little further here. So what would be the next step? Right now I've got the VFO output here. I've just got it patched through. This is where the input of the VFO comes in. And that would be VFO in, which is this pin here, and that feeds this amplifier. It's amplified by 2 stages, and then it's fed to pin 11 of that mixer, Q3. So I'm measuring right at the junction here where the VFO comes up and feeds the counter. And I've got the signal here. And as I vary the, if you can see it, I'm varying the VFO here, and the frequency is changing. You can see it at the top of the screen there as I vary it. So we've got our VFO signal coming into the counter. So that's good. Okay, the VFO is coming in on this RCA jack here, feeding this dual gate MOSFET. Then it's got a source follower here that is coupled into pin 11 of Q3. So let's go to pin 11. There's pin 11, and we are getting signal into the mixer, Q3. The output of the mixer is pin 3. 3 and 11, it looks like it's a balanced output on point D on the schematic there. So I'm going to go to pin 3 first. And you can see, okay, this is a mixer, so it looks like the signal's being mixed here. Let's see if I can get a better shot at that. That's pin 3. And pin 13. And here's pin 13. So we've got signal up here from the mixer. The mixer is mixing one of these two oscillators, which are switched by these two transistors. And that signal there is fed to the input of the mixer. So they're mixing the VFO with one of these oscillators here. So we've got signal at that point. So the next point, the signal's coupled through these two bipolars, and there's an emitter follow here that feeds pin 2 of this 2-input NAND gate, which is Q13. And Q13 is this one here, which is this one here. So let's see if we're getting that signal on pin 2 of that chip. And we are, and it's a higher level. Okay, there's the signal at pin 2, the gate of Q13. Well, if that's supposed to be a sine wave, it looks pretty bad. That may be normal. I'm not sure here. If you look at H, they've got some references here. Here's H, and it's got some pulses that are being fed on pin 3 of that chip. Let's see what pin 3 looks like on that chip. Okay, it is switching, but that waveform looks a little bit different. And that's on pin 3 of the gate. There's a section on the band switch that switches in for the megahertz display. These are diode matrix units here, and if you look pin 5 through pin 15 on the band switch, as you rotate for the different bands, these points are grounded as you rotate through the band switch, and through a switching arrangement here, and using this side of the units here, they drive the megahertz display, which is these two LEDs here. The LEDs over here, these four, these are for the 100 hertz, the 1 kilohertz, the 10 kilohertz, and 100 kilohertz. And their functions are mainly controlled over in this section of the circuitry here. Here you see the connector that goes to the counter. It's the long white connector on top of it there with all the connectors on it. But anyway, that goes down to S1B. This is part of the band switch. And as you switch between the different bands, it sequentially grounds between pin 5 and pin 15. and that's what switches in for your megahertz segments on the counter here. So one thing I want to make sure now is that these pins are being grounded as I rotate through the band switch, because if that doesn't happen, there's going to be a problem. Right now the megahertz display is really flaky. It's not acting right. This show the top of this connector here, this is the white connector, but then up here this round connector is the RCA jack that feeds up from the VCO that feeds into there. There seems to be an awful lot of switching garbage on the VCC line, the 5-volt line here. 78 millivolts peak to peak. Now that would be, I'm measuring across C49 here, which is on the 5-volt VCC line here. I'm measuring on pin 8 of Q23, and that tantalum cap C49 is across the 5-volt line that feeds all these chips, and it seems like there's a lot of junk writing on there, so I'm going to change that change that cap. It's a tantalum, and I've had a lot of bad luck with tantalum caps lately, so I think I'm going to change that, and maybe add a bypass cap too. Let's see where. Yeah, we've got filters over here on the regulator side, but there's quite a long line that runs over here, and these switching chips here are generating a lot of noise on this line. So let's try that and see what happens. There's other bypass caps on these other chips. Here's a 0.047 on Q15. Another 0.047, which is a pretty small cap. I don't see any others over here. S1B is a wafer on the mode switch, and what happens is as you rotate the mode switch through the bands, it grounds pins on the counter terminal here. This is the long white connector, and as you rotate that through, it'll ground each pin. And that connector is this one here, and starting second from the right, the far right one is ground. This one is 160 meters, and this is the actual connections here. You can see as you rotate it, it grounds in succession. 15 is 160 meters, 14 is 80, 13 is 40, 20 is 12, 11 is 15 meters, 10 is 10A, 9 is 10B, 8 is 10C, 7 is 10D, and 6 is WWV. And 5 grounds, although it's not connected to any of the bands, it's one of the two lower ones here that aren't connected. And pin 4 is not connected to anything either. Pin 2 is the voltage in, and pin 1 is ground. So now I want to make sure that the mode switch is grounding the pins that they're supposed to. So I'll start at 160, which will be this pin, and it's grounded. Go to 80, which is this one, 40, this one, 20, 15, 10A, 10B, 10C, 10D, WWV. And that's all of the on the band switch. And then number 5, there's a position on the switch and it's grounded, but it's not connected to any of the bands here. So I know that the mode switch is grounding the proper pins here. And then of course when we connect the connector in, that will ground the proper terminals on the input chips here. There's 2 chips where they connect to determine the megahertz digit. So we know it's good up till here anyway. The second input to this gate comes up from pin 12 of Q12. This is a crystal oscillator. It's got a crystal in it. And that output should be on pin 12, on Q12. So here's pin 12 of that crystal oscillator here. And that is divided down here. So let's see what we have on pin 2. Alright, that looking a little better here. This is the at the crystal oscillator frequency, which is 655 kilohertz. And you can't see it, but 655.353 kilohertz. So we got the signal here, and that's divided down, and that's feeding this gate. So let's go to pin 1 of Q13 and make sure we're getting the signal on that. And that should be, I believe, a 1 hertz signal. Square wave that's feeding the gate. So the output, which is pin 3, which is here, that should be switched Okay, that higher frequency signal is being gated, which it should, from pin 3, and it's fed to pin 1 of Q15. Let's see if pin 1 has, oh boy, pin 1 is buried beneath a bunch of cables here, but I think I can get it here. There's pin 1. So pin 1 is getting, the signal's being gated into here. Pin 12 of Q15, this counter is fed over here to pin 3 of pin 18. And this is pin 3 of pin 18. And this chip counts DO3 is 100 kilohertz, DO4 is 10 kilohertz, DO5 is 1 kilohertz, and DO6 is 100 hertz. Okay. So Q18 has a BCD output between pins, so 4, 5, 6, and 7 are the BCD outputs of Q18. So I'm going to look at pin 4, 5, 6, and 7 of Q18. There's pin 5. And I don't see anything out. Let's check pin 6. I don't see anything. See, this chip is buried under a bunch of cables here. It's kind of hard to see. Okay, we've got signal on pin 7. Let me check these other ones again. Maybe we got a bad chip, which is not likely, but I'm going to check. 4, 5, 6, and 7 again. 1, 2, 3. 4 has signal on it. 5 has a bunch of noise. Nothing. 6 is the same. And 7 is nothing. I'm going to check the voltage on that chip. Pin 18, we should have, on pin 8, we should have 5 volts. And we do, we've got 5 volts. Q18 has got input, and its BC outputs are not good. You see if there's anything around there that could be causing trouble. There's a cap here between pins 16 and 13. And wonder if that's the problem. It's easy enough to replace them. Sometimes, and I've been working on this thing for so long, it's driving me crazy. It's hard to get in here too. There's all these cables that come in from the displays, and chips are buried underneath it. But if this chip is getting an input signal here, and you can't get these chips anymore. It's MSM 5501. I can't find those anywhere. It's some kind of a counter with a BCD output in it. If that's the problem, we're going to have problems here. See, this is one of the old counters from one of the first generations of this transceiver, and it didn't use that special, I think it was a MOSTEC chip, if I remember right, maybe not, but it was a counter chip, and they don't make them anymore. But they don't make a lot of these old regular CMOS and TTL chips anymore either. So that's a problem. Guess I can find a donor. There's some other external counters that Yaesu made that use some of these same chips. Another option would be to find a unit at a Hamfest as a donor. But what I may do, if I pull that chip, put a socket in so I can experiment. There's probably an equivalent that I could put in there for this thing, if that's the problem. But I think I'm going to change that tantalum cap and see what happens, because you just never know. Tantalum caps tend to cause lots of trouble when they get old. I don't know what the voltage rating on this one. It's on a, it's like a 5-volt rail, so it can't be at too high of a voltage here. This has got a double-sided board, and it's got some plated through holes, but I wonder if I've got a problem with the plating between the pins on each side of the board. That's another possibility, because that's acting a little flaky. I wasn't getting any output on these output pins here of Q18 that feed the BCD output that feeds up to this driver. And this is the one that drives these 4 digits. Here, the 100 kilohertz, 10 kilohertz, the 1 kilohertz, and the 100 hertz. And that's multiplexed here. It switches between the 4 here. That gives you your last 4 digits. Yeah, and the newer displays, this was a dim brightness control for the display. On this one, it's to calibrate it. What you do is you set the noise blanker, you 0 beat it, and then you set your 0 your frequency. Here, this is just a trimmer across the oscillator in here. Well, I think it's time to go to plan B. This is getting awful long and drawn out working on this counter here. So I took the counter out of the radio, And what I'm doing is I'm powering it from a bench power supply here, and I'm feeding the VFO signal from the old Clegg that I can vary from 5.0 to 5.5, so I can simulate the VFO in the 901, the Yaesu here. And I'm feeding that in here in the RCA. And of course here is, right here is this terminal here, ground power, and then grounding these separate connections here for the different bands. But this thing still doesn't work, so maybe I can isolate this. And it's a little easier to work on the bench here also. Plus I got my documentation here. So anyway, that's the next step. I'm afraid I might have some bad chips in here, and if I do, this may not be a successful repair. I'll be looking for donors at the Hamfest, so I can tell you that. If someone had saved these chips from years ago, they'd have a gold mine, I'm telling you. I wonder if I have some. The secret would be finding them somewhere in a shoebox. I'm finding a lot of discrepancies in the manual, the service manual I have for this unit here. If you look at Q11, pin 12, here, it shows it connected to the anode of D2907. But if you look on the actual board here, here's pin 12, and it shows it connected to the cathode of that IC. If you look on the board, the actual circuit board, here's that diode here, D07, and the cathode. You can see it's on the right, and that corresponds with the diagram here, the board layout, which shows the cathode facing to the right, which goes to pin 12, and yet pin 12 here goes to the anode. So I'm not sure which one's right. I'm assuming this is right because I'm assuming this counter worked at one time. So unless someone replace that diode and put it in backwards, which I doubt, hopefully, that's not the problem. Here's another discrepancy. Pin 6 on the connector, which is this here. There's pin 6 here. Pin 6 is connected to pin 2 of Q11. There's Q11 here. When I started working on this, that was connected to this pin here, which went to nothing. So here's pin 6 on the connector. Pin 6 on the connector is supposed to go to pin 2 on Q11, and it does now, as you can hear, and that's on this post here. But this connector here that runs up to pin 6 on the connector was on this post here. So once again, I'm not sure. This thing is really becoming a confusing mess here with a lot of rabbit holes. So I moved the pin 6 terminal that comes down through this feed through, I moved it over to this post that's connected to pin 2 of Q11. And once again, pin 6, according to the schematic, goes to pin 2 of Q11. So, I think what I'm going to do, until I can get some more information on this, and I'm going to look at Hamfest and see if I can find a donor. I'd like to find another counter, because this thing is really messed up. You can tell someone had bodged some things in here, and I've spent too much time on it already. So I'm going to end this video. I'm not sure if I'll do another one on this. This is going to get too long. This, like I say, this is one of the older counters. This is before they had that counter chip that seems to cause a lot of problems. Here's the schematic again. This is right out of the service manual if you want to download it. So, radio's working good. Unfortunately, I don't have a counter that works with it, but it's going to be a future project when I get either more information or some more parts. Some of these chips I can't find any information on the internet. They're obsolete, so the chances of finding them are pretty nil. There are some other options though for parts. Yaesu made some standalone counter units that used a lot of these same parts. Here is a schematic of the YC601. This was a standalone counter for the older Yaesu rigs here. And you can see MSM 561. Here's a lot of those same chips that are used. This is pretty much from the same era. So I think my plan is going to be look at Hamfest for a YC601B, and there's another one too that uses the LED readouts on it, the red. And if I can find some of them and get one of them, maybe I can find some extra parts. So anyway, wish I could have fixed this and shown you a working unit with a good counter, but I guess this one has me stumped for a while. So if you followed along this long, thanks for hanging in there, and thanks for watching, and I'll see you in the next one. Bye for now.